So we're going to start with introductions. My name is Rafa Cordon. I am CEO at Simple Proof. Simple Proof is a company dedicated to helping governments, institutions, and companies be able to timestamp their documents and provide evidence of digital documents. I'm here with Peter Todd. You want to introduce yourself, Peter?
Yeah, I'm Peter Todd. I've been involved in Bitcoin and stuff around it for a bit over a decade now. And I also am the founder of Open Timestamps, which is software to go make timestamp proofs.
Cool. So I think, Peter, it's incredible that you came to Guate. We are very excited to have you here, visit us and see this whole thing that we're going to talk about. But maybe let's start with sort of talking about timestamps. What is a timestamp?
Well, I mean, so when I talk about a timestamp, I'm talking about a cryptographic timestamp. And, the word timestamp has been used in a lot of contexts for a lot of things. But in this context, we're talking about cryptographic timestamps. And what they are is basically math proofs that data existed before some point in the past. And I have to be careful about what I'm saying there, because a timestamp proof isn't that the data is valid. It isn't that the data was created on a particular date. It's just that the data existed at some point prior to the past. And a good way to go see this is, if you go to opentimestamps.org and timestamp the data "hello world," which is a phrase that's existed in programming for, decades now, you'll get a proof saying quite happily, oh yeah, "hello world" existed before this date, but it could have existed a lot further back than that. You could also go and, timestamp the phrase "hello Mars." And, well, is that valid? Is that the same as "hello world"? No, but you can still timestamp it. Nothing's going to stop you from doing that. You can timestamp anything you want.
So you could say timestamp is sort of the evidence that something exists at a certain point in time, regardless if it existed before.
Yep. Right. And what's interesting about timestamps is, I'm very careful to go say that they are kind of weak in some ways. The beautiful thing about a timestamp is that the bad guys don't have time machines. Doctor Who is fictional. And because of that, very frequently can rule out certain types of fraud, certain types of manipulation, contamination, degradation, all kinds of stuff like that, just because you can say, hey, this data was created sometime before this point, well in the past, and all the things that could have modified that data were very likely to have happened after that point. A very good example that is actually fairly widely used in the Bitcoin world is when you create a digital signature on a software release. Well, that digital signature is tied to a secret key. If that secret key gets leaked, if people other than the creators have the ability to sign with it, you really want to know, hey, were those signatures created prior to that key getting stolen? If you can say that, if you can prove that, great. You can still verify the signatures. You still know that software has not been tampered with. But without a timestamp, how do you prove that? It's very difficult to. Often you just can't.
Yeah, we're talking about this new technology for timestamping. But if we sort of look in the history of timestamping, it's not a new thing, right?
Secure timestamping is a relatively new thing, but certainly the idea of a timestamp is quite old. And, probably basically after the invention of paper, people already were using timestamps because once you can write something down, you can go and put a date on it and sign it. Of course, when we talk about a paper signature or even a papyrus signature on an Egyptian scroll or something like that, it's a very weak thing because, think about it. If you go and have a pen and you go put your signature on a piece of paper, what's to stop someone from modifying that piece of paper? They can obviously add more ink to other parts of it. And very frequently, that's enough to go modify the meaning of the document. This is why, old school checks for banking, you were supposed to go put a line through the part where you wrote down the amount, because otherwise people would add more numbers to it. Mm-hmm. And there's certain techniques you can use, but it's tricky, especially because, a skilled human can forge a signature. Certainly my signature, my handwriting's terrible.
I've seen it.
Yeah.
Yeah, and going back in time, like I was looking at a bit about like Roman notary publics.
Yeah.
So these were, so I think there was an innovation in Roman times to sort of delegate this responsibility to certain individuals who were known to be trustworthy.
Yeah.
And they would sign that something, they would, attest that something happened at a certain point in time. And so those notary publics were people who have all the, failures of
One of the things
people.
they did was timestamp. Of course, it was a weak timestamp because if the notary public is threatened by someone to go and say a lie, I mean, I'm sure you could get a lot of them to say whatever you wanted them to go say,
Right. And
Human trust is a hard thing. Trust in math is a lot easier.
yeah, and so when did cryptographic timestamping, when was it invented?
I might get the exact dates wrong, but roughly speaking, like the early 90s. And, it's interesting, like Bitcoin is based on a blockchain, a chain of blocks attesting to the integrity of things. Well, funny enough, the idea of a blockchain was, as far as we know, invented for timestamping. Not because a timestamp by itself needs a blockchain, but rather to audit the action of the trusted timestamper. You need to be able to look through all the timestamps they created and go figure out, all right, are they in the right order? Do they, test to the right dates? Does this all look correct? But remember, I'm talking about trusted here. The early 90s stuff, it was all trusted timestamping. At best, you might have some blockchain to go audit it. At worst, a lot of them were just some dude has a key. They go and swear up and down that key is stored securely. It's in a special piece of secure hardware. I mean, it's all well and good, but you're ultimately just trusting that this is all correct. And if that trust fails, if the guy's key gets stolen, if they deliberately sign something that's false, it's very difficult to figure this out. And that's, that kind of thing is actually what inspired me to write open timestamps, because Bitcoin works differently. In Bitcoin, you have blocks, and for technical reasons, for Bitcoin's proof of work, the blocks have a date in them. And the lovely thing about that date is, well, that's needed for the Bitcoin consensus. There's wide witnessing of that date. Many different nodes go see that date and can verify it to at least some degree. And if you can somehow make your data, or I should say, make the Bitcoin block dependent on your data in a way that if your data changed, the block would have to go change, that's a perfectly good timestamp.
Fantastic. And we talk about timestamping as this sort of new concept, but actually it's been embedded in human transactions since the history of trade and like not
or
trusting.
At least the desire to have a timestamp has been embedded. Obviously, when we're talking about a papyrus scroll, the timestamps are pretty weak. But with technology, we get it better and better.
Yeah, but it does have a timestamp. Weak, corruptible timestamps, right? Because in a check, you write the date, so that's a timestamp. Back when sort of like the Industrial Revolution, workers would sort of timestamp their cards. I mean,
you're abusing the word a little bit because it's not quite the same meaning, but certainly some of the concepts are the same. You're trying to show that, hey, this card was punched at this time. And with cryptography, we can just do that so much better.
So but it is a concept that's sort of embedded everywhere that we do transactions, and it's been protected by these sort of weak security until we have something such as the Bitcoin blockchain, which provides like more certainty. Can you talk a bit about the sort of certainty in Bitcoin, like block orders and those things?
Well, I mean, adding a blockchain to a trusted timestamper was already a pretty big improvement, because at least then many people could witness that chain. A good example is the commercial product guard time is a commercial timestamping solution. I think they started in like late 90s, maybe early 2000s. And an interesting thing they do is, of course, guard time has their chain of blocks with the timestamp signatures in there, and they take the cryptographic hash of that block, the sort of the fingerprint, the piece of data that uniquely identifies that piece of data, and they would even publish it in, for instance, the New York Times. So now that piece of data is now irrevocably committed to, linked to by this paper that's broadcast everywhere. There's a copy in the New York Times, at least in the past, there was a copy in the New York Times in millions of people's houses, tens of millions of people's houses. And anywhere you could go over there and say, hey, oh yeah, when did you receive the copy of the New York Times? Well, last week on a Friday, I think. Well, take a look at the number. That number is now mathematically linked to that chain, which is mathematically linked to this piece of data. And those linkages I talk about, all of this is based on what's called a hash function. And a hash function is a mathematical function that takes a large amount of data. You could kind of say it sort of like mixes it up. It's kind of like a blender in a way. But it's a very special type of blender, because if you put the same thing in the blender, the same thing comes out.
Right.
And importantly, the thing that comes out is smaller than the original data. Now, obviously, if you used a blender, this seems a bit magical, but with math, we can make a blender that blends things perfectly every time in exactly the same way. And since the number that comes out, there's no other way to create that number other than having that original data. Well, now you can embed that number in something else. Or you could take two of these numbers from two pieces of data and hash them again, blend them again. Now you have one number. Well, if you can go from two things to one thing, I can also go from four things to two things to one thing, et cetera, et cetera. So scalable timestamps, where you don't have to have, a hash for your piece of data in the New York Times. They're all based on these hash functions by creating big trees of them. And by tree, I mean, kind of like imagine a tree. It's like you have the leaves, but then the leaves go to little twigs, and then the twigs go to branches. The branches go to bigger branches till finally get down to the trunk. That's kind of the visual here. The trunk is that root hash that you go put in a chain or a newspaper or something. Well, since you can do that, now you have all these documents linked to this thing that now is in a place that's very widely witnessed. Well, Bitcoin improves on all this by making this all automatic. Guard time, some dude has to go call up the New York Times like every day and, like list a classified. I mean, that's a very expensive manual process. It's a bit silly. But with Bitcoin, the Bitcoin blockchain is automatically created. Now, Bitcoin blockchain is created to do Bitcoin transactions, but that doesn't matter to the timestampers like us. All we care is that we can get our data in, and that data has a time associated with it, and that time is reasonably accurate. Now, for technical reasons, exact accuracy, there'd be a bit of debate, but for a lot of purposes, being accurate to within a day is already pretty good. And for more sophisticated purposes, you can go see, well, when did other people get this Bitcoin block? Does it all match up? Well, tens of thousands of people receive Bitcoin blocks. It's a huge system. Enormous numbers of people get this data, and it's very easy to get many different references to see exactly when Bitcoin blocks were created. And in practice, the times on Bitcoin blocks are pretty accurate anyway. Miners, the people who create the Bitcoin blocks set them pretty accurate, even more accurate than they really would need to, because, well, synchronizing time these days is pretty easy. We have automated systems that do this. We have protocols like NTP as an example, where you can have one computer will sync to the clock of another computer. And for a computer that like you could own at your home, you can get the timing accuracy down to like millionths of a second quite easily.
Wow.
Yeah.
And so talk a bit about the protocol. How does open timestamps work?
Well, so open timestamps just takes advantage of this tree that I mentioned earlier.
Sorry for interrupting. Let's talk about a protocol. What is a protocol?
Yeah, well, that's an interesting question. So, when programmers talk about protocols, we're really talking about ways of doing things. A protocol for code is really no different than, you can imagine like a protocol for like, how do you act at a dinner? Well, there's a set of rules, and your little 10-year-old knows all the rules, puts the cutlery in the right places, closes their mouth while they're chewing. Like, these are all rules. And you follow these rules, and everything goes well. Well, protocol in the computer world is exactly that, but written as steps that the computers perform. So an open timestamps protocol is really a set of ways of doing things that are all written down in code. And if your computer's using the open timestamps protocol, it means that you're packaging up data in the right way, sending it off to a system that then takes that data and packages it with other people's data. and eventually winds up in a Bitcoin block. And under the hood, all of this is using those Merkle trees I mentioned earlier, so that if you want a piece of data timestamped and another person wants a piece of data timestamped, maybe 10 million other people, we just create a big enough tree with all of this data kind of merged together step by step by step with hash functions till finally we have one piece of data that ultimately gets committed into the Bitcoin blockchain with a transaction.
Why would you put the data in this tree instead of just storing the hash for a single document?
Because it's cheaper. Simple as that. If you want to do a Bitcoin transaction at this moment, if you want to do one on the Bitcoin chain, it'll cost you, roughly $1, maybe $2, something like that. Well, do you really want to spend that money to timestamp your data? Wouldn't you rather spend nothing? And the beauty of the open timestamp solution is by using these trees, we can timestamp all the world's data with one Bitcoin transaction. And, I personally, the most data I've ever timestamped with one Bitcoin transaction was I had a project a couple years ago to timestamp the Internet Archive. And if you've ever gone to archive.org, well, they have copies of basically every website on the internet, going back in time too. This is just enormous amounts of data. I mean, the room we're in, they could fill it completely with hard drives and only barely touch how much data they have.
Wow.
But by creating a big enough tree, all of that data can be crunched down to 32 bytes of data, which goes in one Bitcoin transaction. I think the number worked to be 500 million documents I timestamped in one go. Well, if you know a bit about math, think what's 2 to the power of 31? Well, that's 2 billion. 2 to the power of 30? Well, that's a billion. I mean, it's not a very high tree. Numbers get big really quickly when you double them each time.
Yeah.
It's like the story about the grains of rice on the chessboard. If you have 1 grain of rice on the first square of the chessboard, by the time you get to the end of the chessboard, doubling each time, that's enough rice to bury the entire planet. So it's pretty easy to fit as much as you want. And well, if you have 1 billion documents, 500 million documents in one transaction, well, what's $1 divided by 1 billion? It's basically free.
And so, keeping with the open timestamps protocol, so we're talking about how someone can store information on the Bitcoin block, store hashes.
Well, the important thing to recognize is open timestamps doesn't store your information on Bitcoin. It takes your information and compresses it, if you will, with hashing, many, many layers of this, till you only need 32 bytes on Bitcoin itself. And what you actually get back is mathematical proof, showing how you could take your information and hash it repeatedly to get to those 32 bytes. But that's proof you have to store. If you lose that proof, well, I can't help you. We don't have the data to prove anything about the time of your data. But it's very easy for you to store that data because it's quite small.
Right. How can someone verify that information is stored on the blockchain using open timestamps?
Well, again, you go use software. You use software to verify the protocol. And I mean, concretely, if you happen to have a .ots timestamp proof file, you could go to opentimestamps.org and scroll down a bit, and there's a thing on the web showing, upload to that website your document or proof, then you upload the document and it does the math and verifies it. Of course, you might not want to trust opentimestamps.org. You can even, download that software yourself. It's all open source. It's free to use, free to distribute. And if you really wanted to and knew a little bit about this math, you could verify it by hand. Take you an hour or two to run through all the math, but it's totally possible to do.
So anyone can verify that information, that a certain hash exists using Bitcoin and, the original
the way
document?
I would put it is, remember, it's not about hashing existence, but it's that we have a proof that some piece of data existed prior to some Bitcoin block. Or put another way, to create that Bitcoin block, you must have somehow started with that data. because the math irrevocably leads to that block. These hashes, the only way they can be created from scratch is starting with that data.
And can someone who runs a Bitcoin node, could they verify?
Absolutely. Yep. If they're running a Bitcoin node, their computer is validating all the data associated with Bitcoin and validating that blocks are correct. And they have the information on when blocks were created, roughly, so they can absolutely check all this.
And this is just, doing interacting with a Bitcoin node using the OTS information.
Yep. And, running a Bitcoin node isn't hard. You install some software and just let it sit for a while. It downloads a bunch of data, and eventually you have your node. Honestly, anyone who can install a piece of software can do it. It's not hard. Now, obviously, if you wanted to fully verify this and verify independently that all the math was correct, it might take a bit of work, but there's lots of people in the world who understand how hashes work. This is very, very basic cryptography math. It's not very sophisticated. I actually have a fine arts degree. I don't have a math background. I did some physics, but what it takes to understand this stuff is not that hard. If you have some idea of programming and so on.
And switching topics a bit. So what brought you here to Guatemala?
Well, of course, you guys at Simple Proof went and asked me to come by and look at how you were using open timestamps, timestamp an election. This is the second time I visited, but for this time at least, it wasn't the natural beauty of Guatemala.
Yeah, so we are using open timestamps to take the hashes of every tallying sheet, acta, in acta número 4 in Spanish, and hashing that the digital image of the scanned document, and using open timestamps to put it on the Bitcoin blockchain. What do you think are the implications of doing this for this type of use case?
Well, as I always say, it's important to recognize that a timestamp does one thing, which is it proves that piece of data existed prior to some point in the past. So by hashing these documents as they come in, you create this huge database of digital scans, and you know when that database was created. Now, obviously, if the count was incorrect at the very beginning, well, you're going to hash a tally sheet that has an incorrect count. But if the tally sheet was changed, say a few hours after it was supposed to, well, the timestamp's going to tell you, hang on a second, why was it timestamped 6 hours after the polling station closed rather than 30 minutes? That's suspicious. Now, the timestamp alone can't prove that tally sheet's incorrect, but it can certainly go and prove that other ones were much more likely to be correct, because when they could have been incorrect was a much shorter time window. And, like I say, timestamping does one thing, but in conjunction with other evidence, well, it could go and suggest that, well, maybe those tally sheets were incorrect. Maybe they were modified, And certainly being able to rule that out in other ones makes your job a lot easier. If you can say that, well, 99% of them were timestamped very quickly after the polling station closed, right when we expected them to be timestamped, that's great. And you can focus on the 1% that weren't.
Yeah, there's currently, today, on the 30th of June, there's still a lot of unrest or political parties questioning the voting process. We just did the math and the software.
Yep.
And so the Simple Proof basically helped provide this sort of digital evidence of when voting act tallying sheet was received. But this is only one use case. Maybe this is a sort of very high interest type of use case with a lot of implications. But where else do you see open timestamps being used? Where is it being used right now?
Well, right now, so another big use case that matters is one that I mentioned earlier, which is timestamping digital signatures. And again, the purpose of doing that is similar to these tally sheets, where with a digital signature, if that digital signature was created in the past, close to when it should have been created, and well before any, for instance, suspicion of tampering. That's good. It helps you go rule out that particular signature as being tampered. And, the honest truth is, basically anytime you have archived data, it makes sense to timestamp it. Timestamping is essentially free. The software scales so well that literally the entire world's data can be timestamped with one Bitcoin transaction for, $1. It's just so absurdly cheap that it's one of those things where you might as well go do it. If I were running an archive, as an example, such as the Internet Archive, absolutely, I'd be timestamping everything that comes in, because I want to be able to go and tell people in the future, well, this piece of data that you're getting now, I can prove that it was created 10 years ago. Now, if you want to go argue that it was that it was tampered with 10 years ago, fine, but don't try to argue with me that it was tampered 1 year ago.
Mm-hmm.
And that's just incredibly valuable. Now, obviously, it doesn't necessarily mean that every single piece of data you're actually going to validate the timestamp, or you're going to use it. But because it's nearly free, it's one of those, well, you might as well just do it. Might as well go put that bit of protection on. It's a lot cheaper than, putting locks on your doors.
And right now, like what kind of use cases is timestamps being used? Do you know? Like, of course, it's open source software. Anybody can use it. Nobody has to ask for permission or anything.
Yeah.
But what are some sort of other use cases that you've heard about?
Another example is there's a piece of software for Android phones called Proof Mode, and it's produced by a project called the Guardian Project. And Proof Mode is quite simple. You take photos, record video, and Proof Mode automatically timestamps it for you. And again, the argument is just like all these other arguments. If I can prove that this photo was created, when I'm claiming it was created, or at least prior to that, I can rule out all kinds of nefarious activity. And, it's hard to know this stuff for sure, but I've seen claims that, as an example, in the recent invasion of Ukraine, human rights investigators are using Proof Mode to provide more evidence that the digital data they collect, things like photos of bodies on the street, were actually collected when they claimed they were, and not, for instance, created by AI after the fact. Now, obviously, in this particular case, well, maybe they were created by AI when they were claimed to be created, but frequently that's not an allegation. Frequently the allegation is, no, you modified this after the fact. And being able to rule that out essentially for free, again, you might as well. If you install Proof Mode, you're just downloading a piece of software and the software does it all for you. It uses almost no storage space. It uses almost no network bandwidth. It's just so cheap to do. You might as well do it.
Yeah, with like the new things in AI that are coming out for I see these stable diffusion solutions. I think that enables anyone to edit or modify or create fake digital information in a fairly fast manner compared to back in the day, doing Photoshop and doing it manually.
Yeah.
So I think that
and I should point out, Photoshop fakes are also quite effective. While they may have taken more time and more effort, they were still pretty effective. And even 10 years ago, it was still valuable to timestamp things to be able to help rule that out. And the point I want to make is frequently you can rule this out simply because the bad guys wouldn't have had an opportunity to. If you, as an example, are timestamping all the contracts in your business, frequently the exact nature of a contract, the way you would want to modify that piece of paper and lie, doesn't become apparent until after the fact. You don't know how you want to fake something until some point in the future.
Right.
And then you want to go backwards and fake things in the past to go and make it all match. And that's something Open Timestamps works really well at.
What other use case do you see in the future for timestamping? Maybe like in government, like what kind of...
Well, funny you say that, because sure enough, for a while, if I remember correctly, the Argentinian government, they were actually timestamping their official gazette, their official government publications. And frankly, I suspect what happened there was really simple. There's some IT guy whose job was to go run that website, and he thought, well, why don't I open timestamp it? I might as well.
Some Bitcoiner.
Who knows? I mean, and as it turned out, eventually they got rid of that system and replaced it with some silly trusted thing. But you can see why they would, you can see why the guy would have done it initially. His job is to go record the official documents of the government.
Yeah, because that's where they publish every new law and acts.
Yeah, obviously you want to go and show that these haven't been modified. And, this isn't a theoretical problem either. In the U.S., I'm sure other governments have had this problem too, but I know for a fact this happened in the U.S. Official U.S. court documents, such as official opinions and things like that, there have been a lot of cases where it's turned out that they were modified after the fact by people, making spelling corrections and fixing up the grammar. I mean, and while a lot of this is probably good intentioned, it's easy, even if your intention is to just clean up some badly worded, writing, it's very easy to change the meaning of it in legal meaning. And you don't want to do that. You want to go make it very clear, no, this is what we wrote initially. This is how we fixed it.
Mm-hmm.
This is how we fixed it again. And if you're going to do that, you want this stuff timestamped. It's okay to go and maybe fix a spelling mistake, but there should be a record that you've done this.
Absolutely. Yeah. Like contracts to transfer titles.
Yep.
All these things should be timestamped because I feel it's public information. All these government documents, those are public information.
Yeah.
And everything that the government does should have a timestamp.
Yeah. And, I'll point out there are even more strong cryptographic solutions to this, like single-use seal as an example. But all those systems, they're just harder to implement. They take more work on the IT guy's department. They take more administration to run. Whereas timestamping is just so simple. Why aren't you doing it already?
Scalability. Okay, let's talk a little bit about how, what are sort of some improvements or things that you see in the roadmap for the Open Timestamps protocol?
Well, so the protocol itself, that is the way that, the core of the idea, the way that the timestamp proofs are formatted, the math behind them. Like I said, it scales very well. The underlying math, you absolutely can throw, 1 billion documents at it and create a timestamp proof using one Bitcoin transaction. But in practice, the software that implements that protocol, at the moment, there are some scaling problems with it. I don't currently have the ability to just throw computers at the problem and add more bandwidth to the incoming timestamp requests. So one of the things that's on my to-do list is to go write some additional software to go and actually make that scale in practice. And, we're talking like a month or two of work. It's not really a big deal. It's the kind of thing where if someone asked me tomorrow, oh, shoot, we have to go fix this by 3 weeks. Well, I'd drink a lot of Red Bull and I'd get a solution out in 3 weeks. It wouldn't really be a big deal.
Guatemalan coffee.
Yeah, Guatemalan coffee. Yeah. It's these are all fixable things. Another example is because of how the timestamps are created, you get a lot of what's called calendar data, which is intermediate data that helps create these timestamp proofs. So, when you run the Open Timestamps client, the thing that actually creates a timestamp for you, what's actually happening is you're not waiting for a Bitcoin block to be created. You're just waiting for 1 second to pass. And in that second, that server that's helping create all these timestamps, it takes all of the data that people have submitted for timestamping within 1 second and records the tip of that Merkle tree. So it records 32 bytes every second. Well, if you lose those 32 bytes, there's no way to get the timestamp back. So I wanted to go and improve the Open Timestamps protocol by adding better mechanisms so that people can go back up that data. And there already is a way to back that data up. You can run a special program that talks to these calendars and says, hey, please give me a full copy of everything you have. And your computer will gradually download that full copy. It takes a while, but eventually you'll get there. But I want to improve that process. I want that download process to be faster. I want it to also have digital signature saying, hey, this is the full set of data. You can check to make sure you have it all, rather than maybe you're missing a bit. Just things like that. And none of this changes the underlying math. None of this changes what a timestamp proof is. But it makes it easier to create them, and just less likely that they won't work.
On the scalability issue, it's not really an issue right now.
Yeah, right now, I mean, basically the most number of timestamp requests I get per second, it maxes out at like 100 to 200 requests per second, which for computers really not that much.
Yeah, we're not nearly there pushing the limits.
But I want to be able to accept billions per second. I mean, there really is no reason there should be a limit. If the entire world wants to timestamp all their data, I want to make it possible that I really can help them timestamp all their data. Mm-hmm. And, once I fix these issues and improve the software a bit, timestamping billions of documents per second really doesn't cost that much money. You run some relatively cheap servers for, $1,000 a month or something. And it's totally doable. It just requires better software. And also, a bit of community support. I mean, all this infrastructure runs on donations. And right now, open timestamps as a whole probably costs on the order of, $200, $300, $400 a month to run. And that's split across 3 separate people, including one company who's sponsoring it. But obviously, as we scale up to a bigger system, we'll need more donation money to keep it running. But I'm quite confident we'll find a way to pay for all that. It's pretty cheap compared to, say, running YouTube.
Absolutely. And looking into the future, I was talking about, other use cases, but also, for example, IT systems where, how do you see like companies sort of time stamping their databases? So
this is where companies like Simple Proof will have to come in, because obviously I'm not going to write the software that will help every database under the sun timestamp its data. It's such a huge variety of systems. But because Open Timestamps is a open source protocol, a free to use system, people can write additional software that will integrate within their own systems and timestamp things. A good example is you can imagine a company like selling security cameras. Well, their security cameras record footage constantly, and it would make a lot of sense for them to put in some more code that would take that footage and timestamp it as it came in. Mm-hmm. Now, I'm not the guy who's going to write that code because, I don't run a security company. I don't run a security camera business, but it wouldn't be too hard for them. I mean, in that example, I would be surprised it would take more than maybe a month of work for full time for an engineer to do a prototype of this. Give a few more months of work to make a nice polished user interface. And this is all stuff I want to see happen.
What are the sort of hurdles in adoption that you see that need to be overcome in order for people to start using more open timestamps?
Well, I mean, in addition to having good software, a big hurdle is just people recognizing that the software is available and that this is a problem. And with this recent Guatemalan election, I mean, that's a perfect example of something which will increase the mind share of people who know about timestamps and realize they can be a solution. And the more projects that adopt this, the more people realize this is potentially a solution and that the software works. And you just build up that way. I mean, frankly, that's exactly why I'm doing this podcast, because I want to spread the word. And I think timestamping is important.
Fantastic. So, thank you for all the work you've done, because people always say this, we're standing on the shoulders of giants. And I was like telling my friends at Simple Proof, like, this is the giant, what are the giants whose shoulders we're standing on?
Well, I mean, I will admit from a cryptographic point of view, timestamping is pretty simple, but, just because it's simple doesn't mean someone still has to do it. Yeah. And frankly, like back in about 2016, I'd come up with open timestamps protocol in like 2012, but all I did was create a prototype then. In 2016, still no one had done it properly. There was still no project out there that did what open timestamps does. So I created, I'm going to have to actually write this thing properly. And I sat down for a weekend and rewrote it all and made sure the code worked well. And I just kept working on it. And, it's been running in production since then. A lot of people have used it, and I hope a lot more will continue to use it.
Awesome. Thank you.
Thank you.